This is the final video on the ISA tutorial. Here I'm going to teach you how to download your design onto the CPLD chip in the green board. We're going to refer to this process as implementation. Again, for this video, I need to have my project and design files already created. If you haven't already done so, look at the previous two videos. I want to map these inputs A, B, C to these switches SW1, 2, and 3, and the output F to the LED right here. So to do that, I need to create a file called my user constraint file, which is going to do the mapping for me. So go to Project Navigator and click on Project, New Source. The type of file is going to be implementation constraints file, and then give it a file name. Again, file names have to be unique, and make sure that you follow the rules for naming files. Click on Next and then Finish. As you can see, an empty file is actually created for me. You'll also notice that my constraint file gets added to the top level module, and the top level module is indicated by this icon right here. Now, if I want to actually attach this UCF to another top level module, then I'll have to select that particular file, right click on it, and set it as top module before I create my constraint file. So I'm going to switch it back, set my task 1 as my top level module. Now I need to put something here to do my mapping. So go to my desktop. You'll see something called generic_UCF. Copy everything that's in that text file and then paste it onto the file that Xilinx created. You'll notice here that I have a section for switches, LEDs, and so on. I want A to be SW1, so I replace SW1 by A, SW2 by B, SW3 by C, and my output has to be an LED, so replace LED1 with F. Now go back to the design. I have all my inputs and outputs mapped, so I don't need any other switches, so delete the section for switches. I don't need any other LEDs or anything else for that matter, so delete all of them. Now make sure you save the file. Now go to the hierarchy panel, select the top level module, so this time it's task 1, so make sure that you select that file. Down at the process panel, I should see something called as implement design. Expand that, and under that I should see something called configure device. Expand that, and then double click on manage configuration file. Now while this is running, you want to connect the programming cable and the power to the board. So essentially my programming cable and my power should be connected like that. Now you'll also notice that Xilinx places a check mark by the side of every process that is run successfully. So impact window is how I actually program the board. So when the impact window opens up, double click on boundary scan, and in the white space, right click and add Xilinx device. By default, the project should already be selected for you. If not, browse to the location where your current project is, and then open the .jed file. Now right click on top of your device and click on program. This will initiate the communication with the board, and once it actually initiates the communication, it's going to download the file to the board. And when it's programmed successfully, you should see an icon like that. Now I'm going to test my design. I'm going to compare the results that I get on the board with the results that I got in my truth table. So let me open up the truth table that Modelson generated, and let me open up the board. So in here, the first 3 switches are A, B, and C, and the first LED is F. If the switch is in the down position, then it's a 0. If it's in the up position, then it's a 1. If the LED is not lit, then it's a logical 0. The LED is lit, it's a logical 1. So the first value I'm going to set is 0, 0, 0. And I know that from my truth table, the output I should get is a 0. That's what I'm getting. Now put 0, 0, 1. I know that the next value has to be a 1, which is what I'm getting. And like that, you browse through each and every row, set the value, and then see if you're getting the right output.